Okay, so guys, now in this video we have to discuss the first derivative test. In the previous video we discussed the second derivative test. While discussing the second derivative test, I told you one thing, that if a graph is opening downwards, the maximum, okay, the highest value a graph can achieve, and if a graph is opening upwards, like the mouth is opening upwards, the graph is showing you the value of minima, the lowest possible value the graph can achieve. Okay, but there is one condition in a function in which the graph is continuously increasing, or the second condition, the graph is continuously decreasing. So the graph starts from here and goes all the way to here, and the graph actually starts from here and goes all the way to here. So these are the two conditions in which the graph is continuously increasing, and over here the graph is continuously decreasing. How? Let me show you. If we focus on this point, like this thing right over here, from this to this, the graph is increasing, right? The graph is going upwards, so it's increasing, so there is an increase. But if you focus on this area, the graph is going downwards, which means that it is decreasing. So this area is showing you a decrease, right? For this case, the graph increases from this point to this point, and then it decreases from this point to this point, which means that this area will be positive and this area will be negative, which means that the graph is decreasing, but it's giving you the value of maxima, the maximum possible value the function can achieve. Now if you focus on this graph, is basically decreasing from this point to this point, and over here it is increasing, it is going upwards. If a graph is moving from the negative point towards a positive point, it is increasing, and it is concave up, right? So that's the point where the graph is increasing, but it is showing you the value of minimum. Okay, so it is opposite. The graph is increasing, but is showing you the least possible value. If a graph is continuously increasing, like from this point to this point it is positive, and again from this point to this point it is again positive, so for such a function there will be no relative minima or the maxima, because there is no sign change. And same goes for this one. So let's try some of the practice problems. Now let's try this function. First of all, we will have to take the first derivative, so the derivative of x cubed. So the derivative of x cubed will be 3x here, and the derivative of 12x will be 12. So let's put these things equal to 0, and of course we can simplify these things by taking out the highest common factor. So we have x square minus 12 goes by 3 at 4, so we have 4, and 3 we can use the a square minus b square formula, so we have x square minus 2 whole square, so we have x minus 2 and x plus 2. So there are two values of x minus 2 is equal to 0 and x plus 2 is equal to 0, so we have x is equal to 2 and x is equal to negative 2. So now let's plot the number line for both of these points. So we have 2 right over here and negative 2 right over here. So what will happen if we increase the value? So let's just take 3 for our test point. So now let's put the value 3 into the first derivative right over here. So we have 3 square minus 12. So 3 square is 9 times 3 will be 27 minus 12. So this will be 15, which is a positive value. If the function increases, the value of x increases, we will get positive values. Now what will happen if the value of the critical point lies between these two things, negative 2 and 2? So let's take a value 0. Okay, let's take a test point. So if we put in 3 0 square minus 12, 3 zeros are 0, negative 12, we are getting a negative point between these both of these minimas. So we have negative point. Now what will happen if the value decreases, like we get negative 1? So let's try negative 3. So we have 3 negative 3 whole square minus 12. Now this is the same thing as 15, so we are getting a positive value. The function is behaving in this pattern from negative infinity to negative 2. It has a concave down. It increases and then it decreases from this point, and then from positive infinity to 2, this graph is actually increasing. You see, it was decreasing at this point, and then it goes on increasing. So this is the point where the graph has a minima, and this is the point where the graph has a maximum. Let's put in these values into the original function and let's see what these values give us. So if we put in 2, we have f at 2 will be 2 cube minus 12 times 2, so this will be negative 16. So at 2 we have a value negative 16 of y, of course. And if we put in negative 2, so f at negative 2 will be negative 2 cube minus 12 times negative 2. So it will be positive 16. So at negative 2, we have value positive 16. So x is equal to 2 is my minima, the lowest possible value. This one is my maximum. Now let's try this function. The first derivative will be, so the derivative of 3x square will be, 3 will be separated because it is a constant. Derivative of x4 will be times 3x cube. sorry, 4x cube, minus 8 will be separated and the derivative will be 3x square, and 6 will be separated, derivative will be 2x. Finalize these things, we have 12x cube minus 24x square plus 12x. Okay, so we can take out 12x common, so we have, this will be 1 and the x will be cancelled by the x cube, so we have x square minus 24 divided by 12 will be 2x plus 1. This is actually the whole square formula, a minus b whole square. Okay, so let me just separate this. It will be a square minus 2ab plus b square. So if you see, this is my a minus 2 times x times b will be my 1 plus 1. So this is the same thing as x square minus 2x plus 1. So we can write it in this format, a minus b. So a is x and b is 1. So we can write x minus 1 whole square. We have two values of x. First of all, we have 12x is equal to 0, and then we have x minus 1 whole square is equal to 0. So the value of x will be 0 over here, and over here if we take the square root, x minus 1 will be equal to 0, and then x will be equal to 1. So this is the second value. Let's plot these things on the number line. This will be my 0 and this will be my 1. What will happen if the graph is increasing? So let's take a test point 3. So let's see, let's put in this thing over here. 12 times 3 minus 1 whole square, it will be 72, which will be positive, so we have a positive value over here. Then what will happen between these values? Okay, between 0 and 1 we have 0.5. okay, so let's try 0.5. So 12 times 0.5 and 0.5 minus 1 whole square, so we will get 1.5, which is again a positive value, so we have the positive value. And what will happen if the function is decreasing? Like we get -3. So let's try the -3. So we have 12, -3, and then -3, -1 whole square. At this point we are getting a negative value, so the function is decreasing when we are going from 0 towards the negative infinity. Now let's observe the behavior of this function. From this point to this point it is increasing, so it is going from negative to positive. Then what happens from this point to this point? It still goes on increasing. So we will have a graph like this one. So from here it was negative to positive, and then it continues for a positive value. So now let's put these critical values into the original function and let's find both of the coordinates. So we have f at 0. So this will be 3 times 0, 4 minus 8 times 0 cube plus 6 times 0. So this will be 0. And what about 1? So we will have 3 times 1, 4 minus 8 times 1 cube plus 6 times 1 square. So this will be 3 minus 8 plus 6. This will be positive. So at 0 we have 0, 0. And at 1 we have 1, 1.